Hello, today we are diving into two powerful concepts in thermochemistry, which are bound enthalpies and Hess's law. So the skills are very essential for our students. Let's see the first one, bound enthalpies. So we know that enthalpy change can also be calculated directly from bound enthalpies. And bound enthalpy for a diatomic molecule is defined as the enthalpy change for the following process. So look at this example. It represents the covalent bond between X and Y, right? So when the X and Y bond breaks, it absorbs energy. For example, we have some gaseous chlorine, which is chlorine atom. When it breaks the single bond between chlorine and chlorine atom, it will also absorb energy. But here is the key point. The bound enthalpies are averages when we are dealing with bonds in different molecules, such as methane and ethane. The carbon and hydrogen bonds have different energies, so we use the average enthalpies. And second one is about the enthalpy between bonds. When you're breaking the bonds, you need to absorb energy, and when you're forming new bonds, you will release energy. So we can calculate the enthalpy change. We subtract the energy released by the forming of new bonds from the energy absorbed by the breaking of old bonds. So let's have a look at this example. We need to calculate enthalpy change for the reaction. So how do we solve this problem? We first need to draw the displayed formula. In this reaction, we know which bonds are breaking. It's this one and this one. And which new bonds are making. Okay, let's get started. First, we need to calculate the broken bonds. So the energy will be (410 plus 242), which represent breaking one carbon-hydrogen single bond and breaking one chlorine and chlorine single bond. And the total number is 652 kilojoule per mole. The second step, we need to know the bonds formed. So when you're forming the bonds of a carbon and chlorine, which is 340, and the hydrogen chlorine bond is 431. The total number is 771 kilojoule per mole. Okay, the two steps represent bonds broken and bonds formed. So we can do the third part. We can calculate the enthalpy change by using two numbers, 652 minus 771. So the answer will be minus 139. 37 kilojoule per mole. That's the answer for this question. So, do you understand it? Okay, let's turn into the second part, which is Hess's law. So, the value of enthalpy change for reaction is the same whether it occurs in one step or in a series of steps. The enthalpy change for overall equation is the sum of enthalpy changes for the individual equations. So you can see this represents the calculation. Okay, let's give it into an example. You can look at this diagram. From A, which is some reactant, you can directly go into B, and B is the product. Or you can go with a different path from A to C and C to B, which means you can use this circle to calculate different enthalpy change. In our life experience, it's like climbing the mountain. You can either go with a long distance or you can go from the short distance. Both the enthalpy change are same. Okay, so we can see this one. This is an exact example of combustion. The combustion of both carbon and carbon monoxide. So their products are carbon dioxide. So you can measure the energy, which is minus 393 kilojoule per mole. And for carbon monoxide, it releases energy minus 283 kilojoule per mole. But for our experiment, it's really hard to know this energy, this enthalpy. So we need to calculate through energy circle. You can both go from this way, carbon directly into carbon dioxide. You also can go with two steps, from carbon monoxide to carbon dioxide. And when you put energy together, which come into this one, and you can know the enthalpy change, which is minus 110 kilojoule per mole. Okay, we can see another example. This one looks a little bit difficult, isn't it? And let's use the knowledge we learned from below. First, we can use number 1 and number 2 to represent two equations, right? We can flip the first one. When you flip the first one, it's like this. The enthalpy change will be minus 52 kilojoule per mole. And then you add it with the second equation. When you add them up together, here is the question, what we want you to know, right? It forms into a new product. So the total enthalpy change will be minus 52 plus minus 85, which is minus 137 kilojoule per mole. So isn't it easy to solve this problem? So for industry, we use this more often to solve exact problems. That's why we use this in different ways. Okay, here is the demo class for the chemistry. I hope you like it. Bye.